So when we're doing graphs, a lot of people lose very, very simple marks for not following the simple guidelines you must follow every single time you do a graph. There are lots of different graphs you've got to know about. Scatter graphs, bar charts, line graphs, histograms. And we're going to have a look at how you draw these, how you'd label them up in order to get you the full marks in an exam. And you will either be asked to draw one or to interpret a graph. So there are a lot of different questions they could ask you on this. But as long as you follow the simple guidelines, it's quite a basic topic to get your head around. So what must we include on every graph that we do? We must have a title. Your title must have the independent or dependent variables or covariables on it. You must be able to explain what the graph is actually showing. You must label your x-axis. You must label your y-axis. You will have to put a key in if you're using a key. If you don't need a key for that graph, you don't have to put it in. And also, you've got to correctly label and scale both of your axes. If you don't, you're going to be dropping very, very easy marks. So the first graph we're going to look at is a scatter graph. We know from what we've already learned in correlations that scatter graphs are only used for correlation studies. And it doesn't matter which axes your covariables go on. You can put them any way around. Every mark scheme will have different graphs for the different ways the covariables can be put. So this one here could have gone along here. It doesn't really matter. You can put them either way round on a scatter graph. You will never need to draw a line of best fit unless it specifically states for you to put a line of best fit on. So if you don't get asked, don't bother putting one on there. And again, we've got our title, we've got our axes x and y, our x-axis down here, our y-axis over here. We've got those put in. We've got good scaling down the side. We've got our points plotted accurately. That would be a good example of a graph. So just to recap those key points for a scatter graph. We use them for correlations only, and it doesn't matter which axis your covariables go on. The mark scheme will have it both way round. Well, the most common one they're going to ask you to draw or to interpret is a bar chart. And bar charts, again, require your axes to be labelled up correctly. Your x-axis, your y-axis needs to be labelled, so it needs to state exactly what that axis is. It must have the correct scaling on the side. And also, you must have, and this is really, really important, your independent variable always goes on the bottom, on the x-axis. Your dependent variable, what you're measuring, for example here, study hours per week, always goes on the y-axis. So it's really, really important that you get the independent variable and the dependent variable on the correct axes. And bar charts are used when we've got data that falls in different categories. So you can see here, each person, such as Peter, Zoe, Anna, they all fall separately. So the bars aren't touching. If they're completely different groups, if it's completely different categories of data, you do not put the bar charts next to each other. They should be in separate categories if they're for separate data or separate individuals. So when do we use a bar chart then? It's used when we've got these separate categories, or what we call discrete data. Different people, different countries. They shouldn't be touching. They should all have a gap in between them. And you must remember that the IV is always on the x-axis and the DV is always on the y-axis. So what's the IV? We're looking at the heart rate before and after a slow song, and the heart rate before and after a slow song here. That is it. We are looking at the heart rate. That is what we are manipulating. After a slow song, after a fast song. What we're measuring their heart rate, which goes on the y-axis. You must make sure you're putting your independent variable on the bottom, your dependent variable on the side. Right, histograms are very similar to a bar chart, but you can see all of the columns are touching each other now. And there's a reason for that. Okay, and what it is that it usually is over a period of time. So this bottom x-axis hasn't been labelled correctly, so you would drop marks for that in exam. But this might be, let's have a look. This might be the percentages that someone scores in an exam. Okay, so that's their percentage score down here, whether they have 20 to 30%, 60 to 70%. So this data is continuous. Okay, they're not discrete categories, they're at continuous intervals. So it could be the months of the year, it could be the minutes in an hour. Those things are in a continuous interval, and there's continuous intervals throughout. So that would be when you use a histogram, and these are when the columns that you can see on here actually are allowed to touch each other. So histograms are when the data is continuous, such as the percentage scores in a maths test like we've just seen. You might also get asked to draw or interpret a line graph. And again, you can see there's common mistakes on this graph that would lose you marks in exam. We do not have our title at the top here. This x-axis has not been labelled correctly. It should say months of the year. The title up here should say the number of cars sold during each month of the year. So you've got to tell the moderator exactly what the graph's showing. You must label up your axes. Everything else is good. Okay, the line's fine, you can join up all the dots, the scaling's correct, the y-axis has been labelled, but you'll probably lose 2 marks out of 5 simply for not putting a title, not labelling the x-axis. And line graphs are really used to show how something changes over time. So if it was car sales in a month, if it was your test result scores over a year, we would use a line graph to do that. So if you remember back to doing statistical infrequency as one of the definitions for abnormality, we started to have a look at distribution curves. And this is what a normal distribution curve would look at. For example, if I got the height of everybody in the school, we would generally see that the vast majority of people are in this middle point right here. Some will be to the 50% of the school would be to the right of it, 50% of the school would be to the left of this particular curve. And the mean, median, mode for this data set would be right down the middle of the distribution curve. So we'd be able to work out the mean, the median, and the mode by dissecting the middle of a normal distribution curve. You'd have some at one extreme over here, the really, really tall people, and you'd have the really short people towards the other end of the curve. But that is what a normal distribution curve would look like. And in your test, you've got to know the difference between a normal distribution curve and skewed distribution curves. So you can see down here, we've got negative and we've got positive skewed distribution curves. We're going to have a look at what these mean in regards to the data that they produce. So the first skewed distribution curve we're going to look at is a positive skew. And it's easiest to probably give you an example of how this sort of data set would look like. Let's say I set a very, very difficult test and most of you score very, very lowly. But there's always going to be that little handful that still do really well. So most people score lowly on this particular graph here. So most people are scoring on the low end. However, you're always going to get a few who score really, really well. You know who you are. So this skews the data slightly. We've got more people to one side of the graph and a lot less at the other end of the graph. And the mode will remain at that highest point as you would expect. It's the most frequent one, so it stays exactly at the top of that distribution curve. Then the median will be the next number along, and finally the mean gets dragged here. So because we've got a few people doing really, really well, but most of the class have done really poorly, that will drag the results. Okay, because the average is there, the average results get dragged over to the right, and that's why it's called a right skewed curve, because the mean and the median get dragged to the right because of a few people who score really highly. Okay, most people scored very low, but those few sort of anomalies who scored really, really high and do in every test, then they've dragged the mean and median over to the right. On the other hand, we've got a negative skew. So this could be the complete opposite. I set a very, very easy test. So everyone this time scores really, really highly. Okay, so we're all towards the higher end of our distribution curve. However, a few people still do really, really poorly. Again, you know who you are. And what happens now is that all the data gets pulled over to the left. And that's why we call this a left skew or negative skew. because the median gets dragged down. So most people we know have scored really, really well, but because some people have scored very lowly, these anomalies, they drag the mean down. The mean of the class gets dragged down because there's a few people that still did really poorly in that particular test.